Morning students, today we have lecture number 10 on electric potential and capacitors. So we are solving the numericals. Write the next numerical, write down. Next numerical, a charge of 8 millicoulomb, a charge of 8 millicoulomb, a charge of 8 millicoulomb is located at the origin. A charge of 8 millicoulomb is located at the origin. You please stop. A charge of 8 millicoulomb is located at the origin. Is located at the origin. You please stop. Calculate the work done. Calculate the work done in taking a small charge. Calculate the work done in taking a small charge of. Calculate the work done in taking a small charge of. Calculate the work done in taking a small charge of minus 2 into 10 to the power minus 9 coulomb. Minus 2 into 10 to the power minus 9 coulomb. Minus 2 into 10 to the power minus 9 coulomb. From a point P, capital P, from a point P, bracket P, after the P, bracket P, 0, 3 centimeter, close the bracket. From a point P, 0, 3 centimeter, to a point capital Q, to a point capital Q, bracket, to a point capital Q, 0, 4 centimeter, 0, via a point capital R, a point capital R, bracket, via a point capital R, bracket, 0, 6 centimeter, 9 centimeter. Okay. So this is the given problem, 5 marks. So here I will read the problem once again. A charge of 8 millicoulomb is located at the origin. A charge of 8 millicoulomb is located at the origin. This is at the origin. Okay. Calculate the work done in taking a small charge of minus 2 into 10 to the power minus 9 coulomb from a point P. This is the charge which has to be moved. That means this is a test charge. This charge is to be moved. That means it is a test charge. Calculate the work done in taking a small charge of minus 2 into 10 to the power minus 9 coulomb from one point to another point. That means it is a test charge and this will be a source charge. So this will be a source charge. Identify the charges properly. Work done from point P, 0, 3 centimeter to a point 0, 4 centimeter, 0 via a point R. Okay. So now let us try to draw the diagram, then it will become simple. Okay. So this is on Z axis. This is on Z axis. I will draw this Z axis and that means 0. Okay. This is origin. So at the origin charge Q is placed. Q is placed at the origin. And now 3 centimeter. 3 centimeter. So this is the point P having the coordinates 0, 0, 3 centimeter. Okay. This is point P. Okay. Point Q 0, 4 centimeter, 0. 4 centimeter, that is y axis. So I will write this as y axis. This is point P having coordinate. Point Q, this is point Q having coordinate 0, 4 centimeter, 0. Okay. So now a charge Q0 has to be moved from P to Q via R, where is it is 0, 6 centimeter, 9 centimeter. 6 on y axis and 9 on z axis. 6 on y axis and 9 on z axis, somewhere here. Okay. Somewhere here. So a charge has to be moved from here and then from here. So totally the charge q naught has to be brought from the point P to Q via R. So this is having the coordinate 0, 6 and 9. 0, 6 and 9. Okay, understood the diagram? I am just writing the diagram just as per the coordinates. Okay. So now the charge q naught is to be moved from point P to Q. Okay. So the charge q is the source charge and q naught becomes a test charge. Understood? So now work done to move a charge, from one point to another point. Work done to move a charge from one point to another point is given by charge, that is test charge, into potential difference between the 2 points. Test charge into potential difference between the 2 points. So that is, we have to move from point P to point Q and via this path. Whether the work done depends upon the path followed or not. Work done in this situation is nothing but charge, so it is electrostatic work done. So it is whether it depends upon the electrostatic field, work is done in the electrostatic field, whether it depends upon the path followed or not. It does not depend upon the path followed. Work done does not depend upon the path followed. So the point R does not matter. We have to bring the charge q naught from the point P to Q. So work done only depends upon the initial position and final position. These all the things we know from the theory. So therefore, I will write directly work done to move a test charge q naught, to move test charge q naught from one point to another is given by so work done from where to where? Work done from P to Q. Work done in moving the charge from P to Q is equal to charge into potential difference. Charge into potential difference between 2 points. Potential difference between 2 points. This is the formula. Okay. So therefore, work done in moving the charge q naught from P to Q is equal to, this is charge, which charge? Test charge. Okay. So q naught into potential difference between the 2 points. Which are the 2 points? Point P and point Q. Which one we have to write first? VP or VQ? VP or VQ? Potential difference. VP minus VQ or VQ minus VP? Think about it. So potential difference means final minus initial. In the theory class only I told. First we have to write final, then initial. Finally charge is coming to the point Q. Initially charge is at the point P. So therefore it is VQ minus VP. VQ is potential at the point Q and VP is potential at the point P due to this source charge Q. VQ is potential at the point Q due to the charge small q, and VP is potential at the point P due to the charge small q. So work done is q naught. So q naught as it is. So q naught. So now how to write this formula? VQ, that is we know the 1 by 4 pi epsilon naught q divided by, what is the distance of the point Q from this Q? So from here to here the distance will be, this is y-axis means 4 centimeter. So this is 4 centimeter. So therefore I will write it as 4 centimeter can be written as 0.04. 0.04. I am writing directly. Not okay. I will write the value. Otherwise I will write it as so this is distance on y-axis. No. So I will write it as R1. I will write it as R1 in RF, that is final distance, otherwise RF, I will write, and this is RI, okay, RF minus 1 by 4 pi epsilon naught, that is potential at the point P, 1 by 4 pi epsilon naught Q divided by this distance is RI, that is RI, right? Okay, just so now work done in moving the charge from P to Q is equal to Now substitute the values. Q naught. Q naught value is minus 2 into 10 to the power minus 9. Right. 1 by 4 pi epsilon naught is 9 into 10 to the power 9. And charge Q. Q is the source charge and that is 8 millicoulomb. It is 8 into 10 to the power minus 3 divided by distance RF, that is this distance. This distance is 4 centimeter. 4 centimeter can be written as 0.04 meter minus this one 1 by 4 pi epsilon naught. Once again 9 into 10 to the power 9. 9 into 10 to the power 9 small q, that is 8 into 10 to the power minus 3, and distance is how much? This distance is this is 3 centimeter, no? 3 centimeter. So this is z axis. So 3 centimeter. So that is 0.03. Understood? So therefore work done to move the charge from P to Q is equal to minus 2 into 10 to the power minus 9. 9 into 10 to the power 9. Take common. 8 into 10 to the power minus 3. So all the things are taken common. So you will get here 1 divided by 0.04 minus 1 divided by 0.03. Now simplify this one and get the answer. Simplify this one and get the answer. So on doing the simplification, I will tell directly the answer. On doing the simplification, you will get the answer as, so this is minus, so that will also becomes minus. So you will get 1.2 joule. The final answer will come so to be 1.2 joule. So this is the final answer. This is the work done in moving the charge Q naught from the point P to Q. This is the work done in moving the charge Q naught from P to Q. And this work done is independent of path followed. That is, work done is independent of path followed in the electrostatic field. Therefore, the point R is irrelevant. The point capital R is irrelevant. This work done is independent of path followed. Hence R is irrelevant. That means we did not use the point capital R. So that's what I am telling. Understood? So this is the question. How to solve? Understood? Okay. Simple question. Just we have to identify this diagram and this distances, all the things. That's it. Next question. Turn on the next question. Next question, number you only know. A cube of side B. A cube of side B, small b. A cube of side small b has a charge small q. A cube of side B has a charge small q at each of its vertices. A cube of side small b has a charge small q at each of its vertices. Give please stop. A cube of side small b has a charge small q at each of its vertices. Give please stop. Determine the potential and electric field. Determine the potential and electric field due to this charge. Determine the potential and electric field due to this charge array. ARRAY. Determine the potential and electric field due to this charge array at the center of the cube. Determine the potential and electric field due to this charge array at the center of the cube. You please stop. This is the question. Okay, this much only. So understand the question, read the question and understand the question before solving it. Before solving any physics question, numericals, first try to understand the question. Once you understand the question, then you can think about the solution. Okay. So a cube is there, and the side of the cube is B. Just I will draw a cube, just roughly I will draw a cube. Okay. So see this as a cube. Okay. A cube is there. A cube of side B has charge q at each of its vertices. A charge q is placed at each of its vertices. So a charge q is placed at each of its vertices. Okay. And then so length of the each side, length of each side of a cube is B. They have given the length of each side of the cube is B. All the sides are equal. Okay. Next then, what else they have given? Determine the potential and electric field due to this charge array at the center of the cube. So now we have to determine electric potential and electric field at the center of this cube due to this charge distribution. Due to this charge distribution, we have to find electric potential and electric field at the center of the cube. First, we need to find the distance of the center of the cube from each vertex. The distance of the center of the cube from each vertex. First, find the diagonal. It is the length of the main diagonal. Length of main diagonal of a cube. Diagonal of a cube is given by, that is under root of b plus b plus b, that is root 3 into b. That is, you can directly write it as root 3 into b. So this is length of the main diagonal, that is from one vertex to opposite vertex, the length, that is from here to here, you can say this is these two are opposite vertex, the length of main diagonal. And the distance of the center from each vertex will be half of this diagonal. Understood? Distance of the center, I will say this as center, distance of the center from each vertex, distance of center of cube, distance of center of cube from each vertex. Let us take it as r, and that will be equal to half of the diagonal. That will be equal to half of the length of the main diagonal. And length of the main diagonal we got it as root 3b, so divided by 2. So this is the distance of the center from each charge or from each vertex. Understood? Okay. So now what we want? We want electric potential at the center of the cube. All the charges are identical. All the charges are identical, that is small q only, and all are positive. Okay. So now find electric potential due to only one charge. Find electric potential at the center due to only one charge. So electric potential at center of cube due to a charge at vertex, is given by, so V is equal to 1 by 4 pi epsilon naught q divided by distance of the charge from the center, that we have taken it as r. That's what distance of center of cube from the vertex, we have taken it as r, so I will write it as r. Okay. So this is for only one charge. And now how many charges are there? 1, 2, 3, 4, 5, 6, 7, 8. So electric potential due to these all the 8 charges will be multiplied by 8. So just simple. Or you can use the principle of superposition. Principle of superposition, and then write these points as A, B, C, D, E, F, G, H. So electric potential at O due to charge at A. So like that VA, VB, VBC, VD up to VH, then add them. Both the things will become same. So now total electric potential. Total electric potential V dash is equal to 8 into V. 8 into V. So V dash is equal to 8 into V is this one. That is 1 by 4 pi epsilon naught Q divided by R. So V dash is equal to 8 into Q. Q value is given? No, value is not given. Only they are given the standard values. Okay, 1 by 4 pi epsilon naught. And now substitute the R. R value is root 3b divided by 2. And now simplify this one. So V dash is equal to 2 goes to numerator, 8 into 2, 16. 16 divided by 4. This 2 goes to numerator, 8 into 2, 16. 16 divided by 4. So you will get 4. 4q divided by this 4 is not there, pi epsilon naught b root 3. So this is the correct value. Okay, this is the electric potential at the center of the cube. At the center of the cube, electric potential at the center of the cube is V dash is equal to 4q divided by pi epsilon naught b into root 3. Pi epsilon naught b. B is side. Each side into root 3. Okay. This you can use as a standard formula. You can use as a standard formula also. So if some other numerical is given that charge q, value of the charge q is given, and each side of the cube is given, then substitute the value and get the answer. You can do it directly also if you remember that formula. Okay. Okay, this is electric potential, and now we have to find electric field intensity. The electric field intensity, okay, see here, electric field intensity at the center due to a charge at one vertex. The electric field intensity at the center due to a charge at one vertex is balanced by due to another charge at opposite vertex. Electric field intensity at the center due to one charge which is at vertex is balanced by another charge. Electric field intensity at that point due to another charge which is at the opposite. So opposite vertex. So therefore, so they will cancel each other. So you will get resultant electric field intensity at the center of the cube will be 0. The resultant electric field intensity at the center of the cube will be 0. Resultant electric field intensity at the center of cube will be 0. That is the answer. Understood? So you have to find electric potential and electric field intensity. So electric field intensity will be 0. Understood? Okay. So this is a numerical. So this also from NCERT. So now next question. Write the next question. Next question. Okay. Write on the next question. Next question, number you only know. Two tiny spheres, two tiny spheres carrying charges 1.5 microcoulomb and 2.5 microcoulomb. Two tiny spheres carrying charges 1.5 microcoulomb and 2.5 microcoulomb are located 30 centimeter apart. Two tiny spheres carrying charges 1.5 microcoulomb and 2.5 microcoulomb are located 30 centimeter apart. Are located 30 centimeter apart. Find the potential. Find the potential. Are located 30 centimeter apart. Give list of after apart. Give list of. Find the potential. Find the potential. Find the potential. Next line. Write in the next line A. First one. A. Find the potential A. At the midpoint of the line joining the two charges. At the midpoint of the line joining the two charges. At the midpoint of the line joining the two charges. First one A. At the midpoint of the line joining the two charges. At the midpoint of the line joining the two charges. And B. Right, next one B. In this numerical only A and B. A is at the midpoint of the line joining the two charges and B. Right on B. At a point 10 centimeter. At a point 10 centimeter from this midpoint. At a point 10 centimeter from this midpoint in a plane. At a point 10 centimeter from this midpoint. At a point 10 centimeter from this point. From this midpoint. At a point 10 centimeter from this midpoint in a plane normal to the line. In a plane normal to the line and passing through the midpoint. In a plane normal to the line and passing through the midpoint. At a point 10 centimeter from this midpoint in a plane normal to the line and passing through the midpoint. Normal to the line and passing through the midpoint. Okay. Understand the question first. So, two charges, two tiny spheres, that is nothing but only two charges, Q1 1.5 microcoulomb and Q2 2.5 microcoulomb are separated by a distance of 30 centimeter. Distance between these two charges is 30 centimeter. Okay. Two tiny spheres carrying charge 1.5 microcoulomb and 2.5 microcoulomb are located 30 centimeter apart. Find the potential at the midpoint of the line joining the two charges. First one. Okay. So, let us consider that charge Q1 and Q2 are located at the points A and B, which are at a distance of 30 centimeter. 30 centimeter. Q1 is at the point A and Q2 is at the point B, and the distance between A and B is 30 centimeter. And we want electric potential at midpoint. So, let C be the midpoint. Let C be the midpoint. Let C be the midpoint. Midpoint. Then this distance, that is AC, will be equal to BC. This distance AC will be equal to 15 centimeter and this also equal to 15 centimeter. Now only I will write, here only I will write. So, this distance is 15 centimeter, this distance is also 15 centimeter. Then AC will be equal to BC will be equal to 15 centimeter, that is 0.15 meter. 0.15 meter. Okay. Okay. So, now we want electric potential at the point C. So, electric potential at a midpoint C is VC is equal to VC, electric potential at the point C. VC is equal to electric potential at the point C due to the charge Q1 plus electric potential at the point C due to the charge Q2. Simple. That is VA plus VB. VA plus VB. What is VA? Electric potential at the point C due to the charge at A. What is VB? Electric potential at the point C due to the charge at B. I will write like that. Okay, we can write. So, VC is equal to VA. I will write it as 1 by 4 pi epsilon naught Q1. That is charge at the point A is Q1 divided by AC plus 1 by 4 pi epsilon naught charge at the point B is Q2 divided by BC. So, therefore, VC is equal to, so you will take common 1 by 4 pi epsilon naught is taken common, and also AC and BC both are equal, and that is equal to 0.15. So take that as also common. So 0.15. I'll write here only. So into Q1 plus Q2, simple. So therefore VC is equal to 1 by 4 pi epsilon naught is 9 into 10 to the power 9 divided by 0.15, and Q1 charge Q1 is 1.5 microcoulomb. That is 1.5 into 10 to the power minus 6. Q2 is 2.5, no, plus 2.5 into 10 to the power minus 6. 10 to the power minus 6 is also taken common, and simplify this one. Drop this one. Okay. So VC is equal to 9 into 10 to the power 9 into 10 to the power minus 6 divided by 0.15 into 1.5 plus 2.5, that is 4. 1.5 plus 2.5, that is 4. And on simplifying this one, so on simplifying this one, you will get the answer as, so I will write to the answer, I will give the answer directly. So the answer will come out to be 2.4 into 10 to the power 5 volt. 2.4 into 10 to the power 5 volt. So this is the answer. Do the calculation, you will get the answer. 2.4 into 10 to the power 5 volt. This is the electric potential at the midpoint of the line joining the two chargers. Next, solution for B. Solution for B. B, another part is there in this question. What is that? At a point 10 centimeter from this midpoint in a plane normal to the line passing through the midpoint. Oh. Okay, so now this is A, this is B, this is Q1, Q2. Okay, at a point 10 centimeter from this midpoint in a plane normal to the line passing through this midpoint. So a plane normal to this line, please imagine a plane normal to this line. So on that plane at a point, so that point is at a distance of 10 centimeter from this midpoint. Understood? So at this point we have to find the electric potential. Let's say this point has something A, B, C, D. Okay. So now we want distance of the point D from the A and distance of the point D from the B. Okay. So this value is 15 centimeter, and this value is also 15 centimeter, and this value is 10. So what is this distance will be? What is this distance will be? Using Pythagoras formula you can write. So that distance, I will write here, distance of D from Q1 and Q2 is, from Q1 or Q2, any one charge, I will write, because both are equal. Both distances will be equal, because this is also 15 centimeter, this is also 10, this is also 15, this is also 10. So distance of D from Q1 or Q2 is, how to write that distance? It is under root of, that is 15 square plus 10 square. 15 square plus 10 square. So it is 225. 225 plus 100. So that will come out to be root 325. Root 325. Roughly, I remember the value. Just now I calculated. I remember the value. It will come out to be around 18.0 something. 18.0 something. It is in centimeter, and that will be in 0.18 meter. 0.18 meter. Okay. So now we want electric potential at the point D. So now electric potential at D, due to Q1 and Q2, due to both the charges Q1 and Q2. So due to Q1 and Q2 is Vd is equal to, I will write it as Vd. Vd is equal to, I will write. So electric potential at the point D due to the charge at Q1, due to the charge Q1, and electric potential at the point D due to the charge B. So I will write directly 1 by 4 pi epsilon naught Q1 divided by this distance AD. The distance AD plus 1 by 4 pi epsilon naught Q2 divided by distance BD. You can add them. This is scalar quantity. Electric potential is a scalar quantity. Just you can add. There is no problem. If it is a electric field intensity, then you have to use the vector algebra. No need of vector algebra. Just simply you can add. So VD is equal to. So 1 by 4 pi epsilon naught is taken common, and AD and BD is also same. This distance is nothing but AD is equal to BD. This distance only. AD is equal to BD is equal to 18 centimeter. Okay. So VD is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught into AD. Okay. Into Q1 plus Q2. So VD is equal to 9 into 10 to the power 9. 9 into 10 to the power 9 and AD, value of AD is 0.18. 0.18 meter. So Q1 is how much? How much was the Q1? What was the value of Q1? Q1 value is how much? 1.5 microcoulomb. It is 1.5 into 10 to the power minus 6 plus Q2 2.5 into 10 to the power minus 6. Now simplify this one and get the answer. So on simplifying we will get the answer. I will tell directly the answer. So VD is equal to electric potential at the point D. VD is equal to, so you only simplify it. 10 to the power minus 6 is taken common. Simply 10 to the power minus 6 is taken common. 1.5 plus 2.5, 4. So you will get the value as 2 into 10 to the power 5 volt. 2 into 10 to the power 5 volt. This is the electric potential at the point D. This is the electric potential at the point D. Okay, understood this numerical? This is only I am finding the electric potential, not electric field intensity. Only electric potential according to this chapter. Okay. So now, next question. This is like it looks like it's not a dipole. There's two equal and opposite charges. It's not a dipole. This charge is different and this charge is different, and both the charges are positive only. Okay, so you won't get zero potential. Don't get confused. Okay, next question. You only solve it. This simple. You only solve this as homework. A regular hexagon of side 10 centimeter. A regular hexagon of side 10 centimeter. This is homework. You only solve. A regular hexagon of side 10 centimeter has a charge 5 microcoulomb. A regular hexagon of side 10 centimeter has a charge 5 microcoulomb at each of its vertices. A regular hexagon of side 10 centimeter has a charge 5 microcoulomb at each of its vertices. You please stop. At each of its vertices, you please stop. Calculate the potential at the center of the hexagon. Calculate the potential at the center of the hexagon. A regular hexagon of side 10 centimeter has a charge 5 microcoulomb at each of its vertices. You please stop. Calculate the potential at the center of the hexagon. Calculate the potential at the center of the hexagon. I will give the answer. Answer for this one is potential at the center of the hexagon. It will come so to be 2.7 into 10 to the power 6 volt. 2.7 into 10 to the power 6 volt. 2.7 into 10 to the power 6 volt. This is the answer for this numerical. You only try it. Simple. You try it. You can solve this type of numerical. No problem. Okay. So next. Okay. So these all are some NCERT numerical, some more numericals we will solve in the next class. Okay.